Hello everyone. Today I'm going to talk to you about the Haitian cholera epidemic. I will start by talking about a little bit of background information on cholera in Haiti. Then I will go into how cholera may have originated in this country. After that, I will discuss a few climatic factors that may affect the disease, as well as a few socio-environmental factors that may also affect the disease. After that, I will discuss the current outlook on cholera in Haiti. So, cholera is a disease that is caused by the bacteria Vibrio cholerae. Cholera is a diarrheal disease, so when one is infected, it causes diarrhea or the excretion of water, which, if left untreated, can potentially cause death. It has been very prevalent in Haiti since about October 2010, and it is still quite prevalent, but we'll discuss that later. Thus far, there have been 809,000 reported infections and 9,670 reported deaths. These numbers are reported, so the actual numbers are more likely to be quite higher. The origin of cholera in Haiti is a source of both controversy and debate. There are right now two competing theories. The first one, that cholera is climatic in origin, that it was always there, but not currently infecting humans, as there was an earthquake quite recently prior to the beginning of this epidemic. This is at least plausible. There are a number of factors that earthquakes bring: the disruption of infrastructure, potential flooding, and these may have caused this epidemic. However, the currently most accepted theory is that cholera was introduced to Haiti from the outside. Specifically, it is believed that a troop of UN peacekeepers from Nepal brought cholera into Haiti because cholera is known to be endemic to Nepal, and it really wasn't detected in Haiti before. More specifically, the theory goes that this Nepalese UN troop came to Haiti and set up camp and installed a leaky latrine, which then leaked into a nearby river. This is supported because the initial outbreak of cholera here occurred around this river and this UN camp. So I've talked about the origin of cholera in Haiti, and I'll discuss a few climatic risk factors. This is conducted by Eisenberg et al., who hypothesized that cholera might increase after rainfall. To do this, they analyzed cholera incidents over 20 days after rainfall at a number of different sites. These sites are marked on this map, the first being the Hospital Albert Schweitzer in the Arbanite region. They also analyzed Port-au-Piment in the Sud region, Port-au-Prince, which is the capital of Haiti and is thus a larger city, in the West region, and the USGS rain gauges, also in the West region. The data from this test is shown on the graph to the right here. We have axes for lag, or days after rainfall, the volume of rainfall, and then the relative risk of cholera incidents. So, as we can see, cholera incidence is shown to increase with the volume of rainfall. Perhaps more interesting, however, is that, and this might be a little bit difficult to see on this particular graph, but cholera incidence has been shown to peak approximately 4 to 7 days immediately following rainfall. This information can be used to prepare for greater cholera incidence following rainfall. Now I will discuss a few socio-environmental risk factors for cholera incidence, and this test is conducted by Rebeday et al. And what Rebeday et al. Did was analyze a number of different neighborhoods in Gonaive City. The neighborhoods analyzed or classified, given one of 5 different classifications based on different socio-environmental risk factors. These risk factors include altitude, how their water is sourced, of course, socioeconomic status, and then flood risk. Flood risk is especially important given that cholera is a waterborne disease. And here we see the results from Rude et al. Study. They found that neighborhoods class 4 and classes 3 and 5 had the highest incidence of cholera. Class 4 neighborhoods are hillside, and classes 3 and 5 are coastal neighborhoods. This is important because these different classifications of neighborhoods are affected by different risk factors. For example, the hillside neighborhoods have low water tables, high altitude, poor water availability, poor socioeconomic status, and open defecation. Whereas the coastal neighborhoods are affected by lower altitude and higher water tables, and comes with flooding risk, and as well as open defecation again, and a poor hygiene. What we learned from this is that interventions to individual cities cannot be applied homogeneously. And what I mean by that is that throughout a city, different neighborhoods will require different interventions to be most effective. For example, for the hillside neighborhoods, we might construct latrines or improve hygiene and then construct more clean water sources. For the coastal neighborhoods, we might clear water drains so that the flooding can drain properly, as well as clear the latrines regularly to prevent contamination from flooding. Mostly for coastal neighborhoods, we're going to want to prevent against the consequences of flooding.